Hey everyone. Give me 1 second. I'm configuring the presentation and we'll start in a second. Okay. Perfect. I added the stage. So, I will be doing this webinar for the first time, something like this. So there may be some issues, but I hope that, in the end, everything will work fine. So today I will be talking about my first real critical issue which I found. It was allowing to steal $1.1 million from a DeFi lending protocol. Yeah. And this was a year ago, and was the first bug like this I found. I was very excited about this back then. Okay, when it comes to myself, so I'm doing the hacking for a long time, and I found like 70 critical issues in the blockchain projects. I mostly work with layer 1 protocols, things. So those are Solana, Radix, Ethereum, Sui. Those are layer 1 protocols. Right now I'm mostly doing bug bounties. I managed to make it to top 3 on Hacken proof. And when it comes to some other interesting critical issues, I found even one in a Binance proof of reserves. I was able to prove that they could fake their proof of reserves, which they released if they wanted to. Okay, so let me start you the whole story, how it started with this bug for $1.1 million. So it all started with the Radix audit, which I was doing for the Hacken. So in April 2023, 2 years ago, well, time really go fast. I started an audit of the Radix, which was the layer 1 protocol. And the goal of the Radix was to create a blockchain which is very friendly to user and developers. And I found 8 critical issues in this protocol. So 6 issues were just crashes, which are boring, but there were 2 way better issues. One allowed to mint unlimited number of tokens, and one allowed to bypass authentication, which was an amazing result. So they decided to do another audit in which I found one more issue allowing to mint unlimited numbers of tokens. So the audits are public, and if you want to read them, if you are interested in issues, I recommend to just Google Radix engine Hacken audit. If you enter this in Google, you will find them, so you can read them if you want. Okay, so sometime after the audit, I decided to browse the Radix ecosystem because I really liked it. The technology was pretty good. It was, in my opinion, really user-friendly and developer-friendly. And I just was interested, how the whole ecosystem works. So, I had the wallet, I used many apps they offer. I was even developing some tools for them in my free time. I created a tool which was allowed to generate code coverage for their smart contracts. Later I implemented it also for the NIR protocol. So I was playing with the ecosystem. And at some point, I discovered a platform called Weft Finance. It was in April 2024. So it was basically a lending platform. So you can deposit one token to borrow another. So very basic lending. But it was very interesting because of the one reason. And the reason was that they were offering 82% yield for USDC yes. So a crazy high value. Normally, whenever I see like yield above 20%, I'm suspicious because usually such offers there is something wrong with them or this is a scam. In this case, I mean, they were basically selling it as a guaranteed profit, which was very suspicious to me. And I wanted to know, how is it possible that they're able to offer this such huge returns? How the platform works, how the smart contract works, and everything. So I decided to check it out. Fortunately, they had the whole smart contract open source, and I started to checking it. It was quite long. It was 1,500 lines of code. But fortunately, due to my experience with the Radix and the Rust, it was pretty easy for me to learn it and understand it. So what I wanted to do was to verify that the claims which they have on their website are true. Because on the website, they had information that there are like more than $1 million in deposits and even more, even like $2 million in deposits. There are like $1 million in loans taken. So I wanted to verify that actually those assets really exist on the blockchain, and those are real assets, not some fake one, like same asset used multiple times in the numbers. So I created a program to do this. I basically written a program in Rust which was downloading every information about the loans they have, and then it was checking the loan, who was the owner of the loan, how many assets a given person deposited, just checking everything was correct. Because when it comes to lending platforms, there's one. The most important thing is to have healthy loans. So what does it mean? Okay, so to borrow like, I don't know, $100 in USDC, you need to like deposit $200 in Ethereum. So there's more collateral to pay for your debt, and you need some safety margin. So let's say if it was 50% safety margin, then for each $100 you borrow, you could deposit, you could borrow $50. And if for any reason your value of collateral goes down or value of the debt goes up, because those values are changing, then this debt to collateral ratio is changing as well. So in the situation where you are not able to cover the debt value by your collateral, then your loan needs to be liquidated. So the platform will be basically taking your deposit to pay your debt. And it works well because usually there's the safety margin. So like in this example I shown, it's 50%. So even if the debt raised by $20, so by 40%, the platform still has like $100 which they can take the money from. So they would basically take them from the collateral. So yeah, I even decided to simulate what would happen if I closed and repaid all the loans. So I assume the worst, that like every loan need to be liquidated and all assets need to be recovered. And yeah, I run this program. Unfortunately, when presenting on this platform, which I'm doing right now, it doesn't play the videos from what I see. Yeah, but well, the program worked. That's what I can say. That it was able to extract. It was able to prove that all the information they present of the websites, all the assets, debts, loans, everything works how it's supposed to work, which was great. So the only thing the next thing which was important to verify is to verify if the platform would work correctly if price of some asset changed by a lot. So I checked their safety mechanism, and they had this 30% safety margin for deposits and for the loans. So to put it in practice, when you were depositing $100, you could only borrow assets for $70. So the platform had this $30 safety margin. And it was very unlikely that some assets could change by a lot in a very short period of time. And by a lot, I mean like 50%. So the risk was low. So in general, it looked all good. But I was thinking, after checking the code, I found something interesting. So I decided to dig deeper, and I found a place where there is possibly a bug, and it was liquidation of their loans. So the liquidation is this process when you have too much debt, the platform takes your assets to repay this debt. This is the liquidation. And the thing is, everyone could start this liquidation. So, it was open to everyone to execute it. And the problem which I noticed was that this liquidation approach was very complex. So normally, when you let users do a liquidation, this works in the way that, you pay back the debt of the user in the currency X, and you are able to take the equivalent plus some bonus from the user deposit, which is in a different coin. So this is usually the incentive that you take care of everything, and you get some bonus. And the platform don't need to worry themselves of the whole liquidation process. But however, in case of the Weft, they had a little different approach. So instead of getting the funds from the liquidator first, which covers user debt, they were first giving you the user assets, and then they wanted for you to repay the user debt. So it worked more like the flash loan, for those who are not into smart contracts. Let's explain it in a different way. Yeah, maybe let's show it on the diagram like this. So let's say you have this loan, and it became unhealthy. Debt to collateral is too high, so the platform or someone needs to liquidate it. So the process started that first in my smart contract, I received your debt, your collateral. So you have this $52 debt. I receive as the liquidator $52 in collateral. Normally it's more because there are some bonuses for doing liquidation, but to simplify everything, we're gonna forget about this for now. So when I get this collateral, then it's being removed from the loan, and what the platform wants me to is to change this collateral to the same token or currency which dApp was in. So for example, I take the collateral, I go with this collateral to exchange, I swap it to the same currency as debt, and then in the next step, I repay this debt in the same transaction. So it was using this flash loan mechanism for this. So if I didn't repay the debt in the same transaction, it would just fail. So yes, the same logic as in case of the flash loans. Okay, so this is a very complicated process because it's so easy to make a mistake, especially this part where there is this when we have this temporary state where the collateral was removed from the loan, but it wasn't still repaid. Like the thing is, you can do anything between those two steps. So it's very easy to make this mistake and don't think about some edge case. And I quickly noticed that they didn't think how complex this approach is. Usually, from my perspective, experience, when you are building anything on blockchain or in general, you need to keep it as simple as possible because the complex solutions are very hard to build. So please, rather, it's usually not worth it to implement such complex logic. Okay, so I started to look for a way to abuse it, and I already had an idea how it could be abused. So the platform had another interesting feature, which was called delegated loans. And this means that you can you can have a single, you have a delegator which holds your collateral, so you know the place where you deposit the funds, and this delegator can create multiple smaller loans. So for example, he can, if he deposited $100, he can borrow up to $50, and you know I can take like 3 different loans, like $5, $10, $25, and all of them are separate loans. And this is again very complex logic because, to be honest, this feature wasn't used by anyone. It wasn't even public on the website. Like, okay, there was some documentation about this, but it wasn't used in the practice. So it's again a case where they added a very complex logic, which is just very hard to check every potential scenario with it, and it wasn't even used. That's the kind of the funny part. So avoid situation like this. I knew that, you know, this is the place I should look into the moment I saw the code. Okay, so when you want to create a delegate, like you have your loan NFT, and which doesn't have any collateral with this, you can just convert, you can just connect this loan NFT to the one which has the collateral, and it becomes the delegati. So you have the delegator who holds the deposit, and delegatee which has this dApp. And the function was called link CDP. We're gonna need it later. Okay, but I noticed that there is edge case when it comes to delegate creation. So when loan NFT is converted to delegati, it has to be used. It has to be unused, and when it comes to the code, unused was meaning it had to have zero collateral, because you know the assumption was if the given loan has no collateral, then it's unused loan. There cannot be any debt. So they didn't even put validation that if there's any debt or not, because it was assumed that it's just not possible. And this is right. It was not possible for such a situation to happen. So, but you know, I asked myself a question. Okay, let's say it would be possible. So what would happen if a delegate with no collateral and no zero debt would be created? So there it would be. So here's how it would work. Let's say we have this delegator, we have some assets there, we have some delegati who have a debt for $10, and we want to add another one delegati to delegator, which will have $20 debt. So this is the correct scenario how it should be working. So when I'm adding another existing loan, which has $20, it increases the value of debt in a delegator, right? I mean, I think it all makes sense. So yeah, it's important that whenever there's a change in delegati, the total debt in delegator must be also updated. So this is the correct way it should be working, but probably you already guessed, it didn't work like this, because if I was able to connect a new delegati which already had some debt but had no collateral to a delegator by using this link CDP function, it was assuming that because there is zero collateral, that means that there must be also a zero debt. So the debt wasn't even updated. So it was basically allowing me to add more debt to given delegator. To link more debt to a delegator without actually increasing the amount of debt he had. So as you can see here, this delegator has $30 debt to cover, but in the system it says it's only $10. So it's not an issue yet, but it has potential to be one. This alone couldn't be abused in any way, because what you're gonna get, what you are getting is a wrong. You get more debt in the end, but it's not like it's allowing you to borrow more or anything. So it's just a small bug, of course, for now. So now there's important question: is it even possible to create a loan with no collateral? And the answer is no, unless there is some special case. And it happens that there is some special case where actually for a moment we can get a loan which has less collateral than it's supposed to have, right? Like here, I'm able to take the $52 of collateral for a moment when I'm starting this liquidation process. So for a moment, I get this loan with a less collateral, but the goal is to get to the zero, right? We are still having $48 in this loan, which is a problem. But fortunately for me, there was an easy way to get it to zero. And it was another bug, a very small one, which normally wasn't even, it would be a low severity issue. But for this case, it was perfect. So there was a bug which was allowing me to start liquidation of the same loan multiple times. So I would basically do this. So whenever I could start with taking $52 collateral to repay the debt, then the value of collateral goes down, but the debt is still here. So I can still start the second liquidation of the same loan, take 48 collateral. So I will move the whole collateral to zero. But this is causing a problem, a bug, because then at the end of transaction, I need to repay the debt, right? So actually, I need to repay. I took $100 from the collateral, which I need to repay at the end of transaction. But the thing is, there's only $52 of debt to be repaid. So when I'm trying to repay $100, the transactions would fail because, I would try to pay more than there is debt to repay. So yeah, it would end up in an error. However, there will be solution to that. Okay, so let's ignore for now that there is this issue which is causing this transaction to fail. We'll deal with that later. And for now, let's focus on the delegators and delegates again. So the goal was to create this loan, which is gonna have 0 collateral and 50 and some debt. So we managed to do this. We have this loan, it has 0 collateral, it has $50 debt, and now we can, because the system is thinking that this is a fresh loan, it's like has 0 collateral, which means it has to have also 0 debt. We can link this loan to a delegator and convert it to delegati. So we basically convert the loan to a delegati which only has debt, and this debt is not being added to delegator. But still, when we try to repay the loan after that, it still fails because we have this $100 repayment and we try to repay only $50. Yeah, so that's it. But there is solution for that. And if you want to figure it out yourself, because you don't need to have like the more information, you can pause right now and think about this, because the solution is actually pretty simple. And if not, I will be telling you how in a second. Okay, let's go. So the solution is simple. So before repaying this $100, we just take another loan for $50, because right now, when we linked this new loan to a delegator, if this delegator have enough collateral, let's say, $200, this means that we can use that to even take more debt. So we are starting this transaction like this. Okay, we have this loan which will be liquidated. We start liquidation twice. We get $100 of collateral. We get $50. We have this $50 of debt. Then, because we have the 0 collateral, we can link the loan to a delegator. But now we need 100. But now we need to increase the amount of debt to be $100. So the repayment at the end will work. And we do that by simply taking this another $50 more loan. So we end up with a delegate having actually $100 debt. And then when we do the repayment, it works correctly, because now we repay everything. So by doing these few interesting steps, we managed to make it work. So yeah, so if you wondered why you don't implement such complex solution, or especially why you shouldn't implement flash loans, this is the reason why. Because you can do so many things in between, and if you are not prepared, then someone can abuse it. Okay, so now the question is, what do we basically manage to accomplish? How to abuse it? So to simplify everything, we start with this liquidation. We have this loan with 0 collateral because it was taken. And then we are linking this loan to a delegator. We take $50 debt to repay, to increase the debt to $100, and then we can repay it. Okay, so the important thing is the place where the bug is will be a delegator, because it's about this bug which I was showing previously. This one which was increasing the amount of debt when linking with a new loan. Actually, it wasn't increasing it, so it was staying the same. So let's see how it looked in the practice. So when I started the liquidation of the loan, okay, let's assume that at the beginning we have this delegator. It has $400 collateral. It has already $100 of debt. And yeah, there is this one delegate one. He has this $100 of debt. Okay, we start liquidation of a different loan, which is having this $100 collateral and $50 debt. So we start this liquidation, and then when we have this $0 collateral and 100 debt, we link this loan to a delegator. And what happens is that the new delegate is being added. He has this $50 of debt, but due to this bug which I was talking about, the sum of the debt is staying still at $100. So in practice, it means that the delegator can take another $100 loan. Okay, so in the next step, we are taking $50 more debt, which we need to repay to finish this liquidation process. And when we take this more debt, or we take it for delegate 2, and it is already linked. So in this case, the sum of the debt is also increasing by this $50. And the most interesting thing happens at the end. When we now repay $100, the sum of the debt is also reduced by this $100. So it's reduced to the $50. And we basically had a transaction where we didn't lose any money. In the end, it costed us $0 because we deposited $100, then we recovered this $100, but we were able to lower the sum of the debt by $50. So this is where the bug is, that because it wasn't, this $50 wasn't added when it was linked to the delegator, it wasn't, because it wasn't added then, it caused that when this debt was removed in the liquidation process, the sum of the debt was lowered by the full amount, which allowed to lower this whole debt obligations of delegator to by $50. So basically, it was giving this $50 advantage in a single transaction, and it was costing nothing to run it. So I had this whole working process, and now I had to prove it by coding it and actually executing on a local copy of the blockchain. So I started to work on this. So to summarize the exploit, by creating a delegate during liquidation process, we are able to modify the sum of the debt of delegator during end of liquidation. And this was possible because debt of the new delegati was not being added to sum of debt. And this bug in business logic of the application allowed borrowing more than permitted. So by having this advantage, I could, in practice, borrow as much as I wanted. So I could borrow everything without having a real collateral to cover the costs. Okay, so I started to work on the exploit. In my case, when I'm working and I'm getting excited about something, I cannot sleep. I need to have the solution ready as quickly as possible. So I spent like 2 next days only coding this exploit. It was like 1,000 lines of code, and I ran it. And because of the video doesn't work here, it was basically doing around 1,000 transactions, and with each transaction it was gaining more assets under control. So I started this simulation with having like $1,000 for the first loan. So that from this $1,000, I was able to get 250 extra dollars, and in the next step, I had $1,250. So it was like exponentially growing this this amount of assets which I had. And the platform had around $1 million in $1.1 million in total assets. So so by repeating these steps with getting more and more with every transaction, the exploit was able to extract everything with just this 1,000 transaction, something like this. But fortunately, there is a screen with the end results of the exploit, and as you can see in this, it was able to extract all there was possible. And in the end, when everything would be converted, it would be $1.1 million. So yeah, 1,000 transaction. An exploit needed 15 minutes to run. And of course, it was executed on my testnet, so it wasn't executed on mainnet. Okay, so you may wonder what happened next. So I contacted with the Weft finance team. I found their telegrams, and I messaged them that I noticed a potential bug in their liquidation process. Do you offer any bug bounty for critical issues? And they said, we don't have a bug bounty right now, but we are planning to run it. And in general, yes, if you have a bug, then we will pay for it. So perfect. It was before I started to coding the exploit. And so after having this confirmation that, okay, they are willing to pay something, I started to work on this exploit. And after I finished it, I contacted them again. I shared everything with them. How to run what the issue is, how to run the exploit, and I agreed on the terms what we are going to do next. And so it also comes to the bug bounty. And yeah, after they checked everything I shared with them, they fulfilled their side of the agreement. I helped them fix the issue, and I also reported them all the other small potential issues which I noticed, and they weren't like very harmful, but they had to be fixed just in case, because as you can see even in this exploit, and usually it is like this, all the issues, this exploit had to like abuse 3 different small issues. Each issues on their own were not harmful. It wasn't possible to abuse it in any way, probably. But the thing is, sometimes you can connect those very small issues, and in the end up with critical issues. So, and the last thing was when they finally fixed this issue, I staked $11,500 on their platform, because come on, they were offering 82% yearly returns. So I was basically getting, let me calculate it, how much should it be? 82%, 365. I was getting just, $25 a day for this deposit. So it was a great deal. And I was able to use it for half a year because then the rates weren't so high anymore and I moved somewhere else. So yeah, it was a very good deal. I deposited even more later. But let's assume what would happen in the worst case if someone else would find this issue, someone who wouldn't have a problem to abuse it. So if someone managed to do it, the platform would lose $1.1 million in asset, and most of them would be in Radix native tokens. So also the Radix, the whole ecosystem would be very damaged. The web would, have no other option than face bankruptcy. Their token, which had like a $2 million market cap, would go immediately to zero, and it would be the first hack in Radix ecosystem, and it would damage it by a lot. So it would be a pretty big deal for them. So let me talk about some recommendations how to avoid such situations. So first of all, do not keep features which you are not using in your smart contract. I mean, you should avoid putting things there just in case, like they did, or the things which will be implemented in the future. The problem with Radix was that they didn't have upgradability mechanism for the smart contract, so that's why they decided to put everything in the current list. So the next thing, which I was also saying already, is to keep the things simple. Don't add the complex logics like the flash loan, like some advanced mechanism for debts, liquidations, delegates, because those things are very risky. It's very complex. It's very easy to make a mistake. And usually no one is using them, or like 1% of users. So they are rather not worth it. Have a lot of tests, test everything, because 100% test coverage is your target. If you cannot test something, then don't write it. This is the basic rule. Have an audit. I mean, if the Weft Finance had an audit, which actually they had, but from a different company, I don't remember the name, they wouldn't have this problem, because if an auditor found even one of the small issues, like that you can start this liquidation twice, it would be enough to stop this attack. But unfortunately the one they went with didn't. So I recommend to work with auditors who have some history. Okay, and in the end, have a bug bounty program. There are many of them available. So the other people would be interested more in reporting the issue than deciding to steal the money. For example, Hacken proof is great. I mean, that's what I'm mostly doing when it comes to Web3 right now. Stuff for Hacken proof, finding issues there. Okay, and there are also important tips for the new ecosystems, because all the story wouldn't happen if I didn't audit Radix. So every new blockchain ecosystem and protocol should collaborate with auditing company, and it's not just for them, but it's for the whole ecosystem. It's a good thing for the whole ecosystem to have someone to even recommend to their users that, okay, this company or this guy can check your code. And even if your project, your team is amazing, you need to keep in mind that other teams may not be so good at what they do. They may or they can just make a mistake, and they can also harm you or entire ecosystem. And this thing happened with Sui recently. you remember the Sui had this, there was this, I don't remember the name of the platform, but there was one project which got hacked for like $50 million in the end. And in the end, it was Sui which had to like cover those money and like to give the loan to the platform. So it was exactly this. And I was speaking about this already a year ago. So you can see how important it is that in this blockchain where we have so many connections between different projects, then entire system ecosystem is taking damages when something like this happens. Okay, and of course, every ecosystem should implement a bounty program for all the applications, as it's more cost-effective to pay bounties and prevent disasters than to handle the aftermath of a hack. And this is also exactly what Sui did after this situation happened. Right now, like if there's an issue in ecosystem or in this project there, they are also paying a bounty for this. So they implemented those advices. So yeah, I think they will work pretty well. Okay, so yeah, so if you need someone to check your code, if you need to test, find issues, or just review if what you are doing makes sense, then feel free to contact Hacken for that. We are pretty good at this. And there's also a Hacken-proof platform which can host your bug bounty program, which is also a perfect place. And in general, when it comes to audits, right now they have this amazing thing which is called dual defense. So, after the audit, there's a community audit if the code is the open source of the project. So even if auditor failed to find some issue, but like some bug hunter will find it later after the audit within 30 days, then this bug hunter will get the money for himself. So it even happened twice so far. So which proves that this makes sense. Actually, there was some issue missed, and later it was found by a bug hunter, and he managed to get the money. So I guess everyone was pretty satisfied in the end, because you avoid the issue. Bug hunter gets the money, and Hacken avoids having a missed issue in their project, which I think is a pretty cool approach, and sooner or later we'll see it in more or if not all auditing companies. Okay, so if you have any questions, then feel free to ask them on the chat, and I will be there for some time, few minutes, let's say, to answer your questions. I'm using this platform which is like integrating all the chats, so I hope it's giving them correctly. Maybe not. I will just, just in case, I will check myself, like on X, maybe, to see. And of course, I invite you to follow my X, Twitter, profile. I post there some interesting issues sometimes, because funny thing is that I said it was my first issue in which it was possible to steal $1 million, and since that moment I had more issues like this, and we'll be talking about one of them on Ethereum Warsaw. So later there will be presentation also on X. So yeah, I give it a try. Okay, I have 2 questions, so let's go. First question, what tips you would give to new auditors? Okay, so the first tip is, of course, use AI. I mean, I use it a lot. So my main AI which I work with is Google Gemini. I also work with the Cursor, and I use it to quickly explain me things which I don't know about. To verify some ideas, to write exploits or proof of concepts. So this is like the most important thing. And I would later focus on checking the other issues, how they were found, or what was the idea behind finding this issue. So like in this case, I found this issue because first of all, it was by chance, but I had this hint that the logic there is too complex. It's and there will be some edge cases which are not covered. Yeah, so that's the thing, and because I already knew a lot of different issues, it allowed me to know where to search for them, and that's a pretty important thing, like to have this knowledge of the other issues. Or maybe even sometimes, I wouldn't like read about the all details of the issue, but I would just take a hint that there was like issue in some project, and they can even be information what the issue is about, but I would take this challenge to find this issue myself without the more details on the version which is not patched yet. Because there's one important thing, every project had the critical issues. The Bitcoin had them, the Solana had them, the Ethereum had them, Sui, Aptos, all of them had the critical issues at some point. The projects are so complex that this is not possible to avoid issues. All the projects will have them, and you can learn from them for sure. Okay, I hope it helps. Okay, and the next question. Are the Cifrin videos a good start for becoming an auditor? I don't know because I didn't watch them, so I don't know if the videos are good. In my case, because before starting with cybersecurity, I was doing been in IT for around 10 years already. I had a lot of experience, and usually this experience was coming from my mistakes. Before doing audits and Web3 in general, I was working a lot with game servers, and so that was the place when I was, and it was all in C++, so that was the place where I was learning a lot of mistakes, and things related to this performance, to the cybersecurity and stuff. So in your case, the answer is I don't know. Okay, and the last one. What smart contract language do you do bounties in, including this one? Usually I don't work with the smart contracts. I also didn't work with... okay, this is actually the smart contract, but and it was in Rust, but usually I don't do smart contracts. I do layer 1 protocols, and mostly with Rust. When I started at Hacken, I was doing it in C++, but then I moved to the Rust, because actually if you are using C++ in 2025, then this is a red flag for a project. So there are going to be issues for sure, especially if there's a new code added. It's too easy to make a mistake in C++. So I moved to Rust, and I mostly work with right now with Sui and Aptos and some other layer 1 protocols in Rust. for this year, I decided that I will become an expert when it comes to move ecosystem. So that's why it includes the Aptos and the Sui. But right now, when it comes to bug bounties, I'm on a break. I didn't do any bug bounties for last 2 months. The things which I post on the Twitter on X are mostly from the bugs I found like 3-4 months ago. So this is just for reference. But I will be back, and there will be more issues found. So yeah. This is because I actually never audited Solidity. This may be interesting to you. I understand everything in Solidity, how the smart contracts works, but I didn't audit them, or I wasn't creating any complex Solidity smart contracts because I try to avoid the most popular projects, because there are already plenty of developers and people working on that, and the competition is tough. So I stick rather to less popular projects. So yeah, this is the answer. I don't see another questions, so I will be finishing this workshop, this live stream, and there will be another one. I don't remember exactly when, but in like a week. Anyway, just follow the Hacken profile on X, or my profile on X. You can also follow 2 of them. It's allowed. I even recommend it. So you will stay up to date. I hope you enjoyed it, and you will also join the next live stream. Thank you. Have a great day. Bye.